This is complex numbers and roots day 2. Just a little reminder, if we're talking about an imaginary unit, I is equivalent to the square root of -1, and I squared is -1. The reason why I say that is because I, we know, is the square root of -1, and if we square that, the square root and the square cancel each other out, leaving me with that -1. Today's objectives are to add and subtract, multiply, and divide complex numbers. It basically is treated as if the I is a variable, much like X. Let's start with adding and subtracting because that's going to be the easiest. For part A, if I am adding, then we just end up keeping all of the signs. So I can rewrite this as 4 minus I plus 3 plus 2I. Now, we're going to combine like terms. We want to add the real numbers together and then add the imaginary numbers together. When we write our answer, we want to write it in standard form. So that's A plus BI. A being the real part and BI representing the imaginary part. So I'm going to add my real numbers together first. 4 plus 3 is 7. And now I need the imaginary part. So I'm going to add my -1I and my +2I. So -1 plus 2 is a +1, which means I have plus 1I, or just I. So if we're adding, we keep all of the signs. If we're subtracting, we need to distribute the negative. So I would leave the first set of parentheses alone. So I have 7 minus 5I. And I am subtracting 1 minus 5I from the 7 minus 5I. So I need to distribute the negative to both terms in that second set of parentheses. So I have a -1 and a plus 5I. Once again, we would like to combine like terms. I'm going to add the real numbers together first because the real number is first in standard form. So 7 minus 1 is a +6. And now I would want to look at the imaginary numbers because that's what comes second. A -5I and a +5I actually cancel each other out. So I could put plus 0I. If I wanted it to be completely simplified, because it's 0I, there is no imaginary number here. I could write it as just 6. Part C, we have 6 minus a -2 plus 9I plus a -8 plus 4I. So I'm going to go ahead and rewrite this. When I subtract this set of parentheses, I must distribute the negative. So really, this becomes 6 plus 2 minus 9I. And now I am adding a -8 and a +4I. So because this is addition, I could just keep these signs here. So I have -8 and plus 4I. Okay. Once again, I want this to be in standard form, so I need to look at the real numbers first. A 6 plus 2 minus 8 would become +8 minus 8, or 0. And now I want to look at the imaginary components. So -9 plus 4I is a -5I. Because there is a 0 for the real numbers, this is purely an imaginary number, so I can rewrite it as -5I. So if we look at our solutions for part A, my solution is 7 plus I, which is a complex number. For part B, my final answer was just 6, which is a real number. And for part C, my answer was a negative 5I, which is an imaginary number. I'd like you to pause the video and try to add and subtract the next 3 problems. Feel free to pause the video so you can check your work, but for the first one, you should end up with 9 plus 4I. The second would be 12 minus 10I, and the third is 3 plus 6I. For example 2, we are now going to be multiplying complex numbers. Again, I'd like you to treat I just like how we would treat the variable x. That's going to make this a lot easier for us. For number 1, I have a number on the outside being multiplied by a parenthesis. So this should look familiar from your algebra days. We need to distribute the 5I to each term that is inside of the parentheses. So 5I times a negative 2 would give me a negative 10I. And then a 5I times a positive 1I. Well, 5 times 1 is 5, so I have plus 5. I times I is I squared. Now, we want to write this in standard form once again, which is A plus BI. This does not look like standard form at all. And the problem is there is no I squared in standard form. But remember, we do know something about I squared. I squared is equivalent to negative 1. So we're going to substitute in, put substitute negative 1 for I squared. Okay? So if I do that, I have negative 10I plus 5 times, in place of I squared, I'm putting a negative 1. Meaning I now have negative 10I, positive 5 times a negative 1 is a negative 5. Well, this is still not in standard form. Standard form has the real number first, and then the imaginary number second. Meaning that I need to put that negative 5 out front, so negative 5. And then my imaginary component, the negative 10I second. Making my final answer negative 5 minus 10I. Number 2, now I have a parentheses times a parentheses. Whenever we see this, we would like to FOIL. Remember, FOIL stands for first, outside, inside, last. So if I multiply the first terms together, positive 7 times negative 1 is a negative 7. The outside terms, 7 times 2 is 14, and there was an I, so 14I. The inside terms, negative 4 times a negative 1 is a positive 4, and there was an I. And then my last terms, negative 4 times a positive 2 is a negative 8I squared. Okay? So now what I need to do is clean this up a little bit. That gives me a negative 7, 14I plus 4I. These are like terms, so I can combine those. That would give me plus 18I. And then here I have an I squared. Remember, we can substitute in a negative 1 for the I squared, so I have negative 8 times negative 1. Well, negative 8 times negative 1 becomes a plus 8. So really, I have negative 7 plus 18i plus 8. My answer needs to be written in standard form, so I'm going to scooch this over a little bit. Remember, standard form, the real number is first and the imaginary number comes second. So I'm going to combine my negative 7 and my positive 8, leaving me with a positive 1. And then I'm going to use my imaginary number, so I had a positive 18i, meaning the final answer is 1 plus 18i. For number 3, once again, we are going to FOIL. First, outside, inside, last. Remember, that's what FOIL represents. So first term, 6 times 6 is 36. Outside terms, 6 times a negative 3i is a negative 18i. A positive 3i and a positive 6 for my inside terms, so that becomes a positive 18i. And my last terms are a positive 3i and a negative 3i, so that gives me a negative 9i squared. I want you to notice that the i's cancel out, and I'm left with an I squared, which remember we need to substitute a negative 1 for that. So really I have 36 minus 9 times negative 1, or 36 plus 9, which is 45. That means our final solution is a real number of 45. If you were to write this as a complex number, it would be 45 plus 0i, but this is technically the most simplified answer, so that's how I'm going to write it. I'd like you to pause the video and try these 3 problems before we move on to dividing complex numbers. As always, feel free to pause the video and check my work if you got the incorrect answers. But for the first one, I distributed the I and ended up with negative 1 plus 3i. For 2 and 3, I FOILed both of those. I ended up with 44 plus 3i, and I did write it as a complex number, but technically the most simplified answer would have just been 74 for the third try problem.